Hey, good morning and welcome to day 160. It's more filters and color combinations, color addition and color subtraction. We've got how many goals today? 3. So, first, write a sentence explaining how the combination of indigo, what color is indigo? We should know. It's a color that somebody made up. It's kind of like purple. And orange, how does that create red light? Interesting. And let's see, state the result of white light hitting a partially absorbent surface or filter. So if you shine white light that has all the colors in it, what happens when that hits something that absorbs some wavelengths, aka some colors, but not all? And then I want you to try to use filters to produce a color. So if you were trying to get a certain color output, say you're trying to take a photo and get a certain color output, how would you do that with filters? How could you do that with filters that you put over the lens of a camera or filtering film? This is kind of fun stuff. And if you have any filtery stuff at home, I know some of you did this yesterday, you can put them in front of the camera on your phone and take some interesting pictures. It's kind of fun. Hey, buddy. Okay, so we got a warm up, and let me move the shot of myself out of the way here, and go ahead and take a minute and do it now, and pause, and then come on back. What are those? What are those? Okay, so when you see indigo, which two colors are being combined to create that color? When you see orange, which two colors are being combined to make those colors? So you can use our color simulator from yesterday. The link is right here. And here it is. Okay, it's going to load again. I have it loaded, I promise. I preloaded everything for today. I preloaded everything for every day. And then as soon as I turn on Screencastify, it unloads everything. And then you have to start all over again. So how do you make orange? You think there's blue and orange? I don't know. Let's try green and red. What? Let me take off the shades. There we go. Orange. What about indigo? Look how we can adjust the orangeness of the orange. Oh, that's more orange. Ooh, that's even better. Okay, so it's not an even amount. Hey, Lou.
Huh?
Hey, what you got? Is your hair all done? You're 10?
Daddy, let me do it to your hair.
What are you going to do to my hair?
I'm braiding it.
Oh, you're braiding it?
Yeah,
Okay.
because Mommy did that to my.
Oh, that's kind. You want to say hi to everybody?
Hi.
All right. Then what color is this?
Orange.
And which two colors are these?
Green and red.
And so green and red, when you add them together, what color do you get?
Blue.
No, what color do you get? This color.
Orange.
Orange, yeah. Do you have to go potty?
Yeah.
Okay, why don't you go potty? Okay, what about indigo? I don't think there's any green in indigo. So let's cut that out. And let's try some blue. Ooh, there we go. So a mix of red and blue gets you indigo. Okay. There we go. So some color addition rules. Well, so here's a little color, almost like a color wheel in a way. It's not the color wheel, but it's kind of like that. So if you add red, blue, and green together, you get white. If you only add two of these, though, then you get other colors. So red and blue gets you magenta, red and green gets you yellow, and blue and green gets you cyan. And I'm just going to give you a little heads up. If you've ever changed the ink in your printer, you know that the colors in the printer are not red, blue, and green. So the colors of light that we get from, say, a TV or a computer monitor are generally red, blue, and green. But when we're printing, we actually use a different principle. We use magenta, cyan, and yellow to make all the colors. We'll talk about why later. Not today. So these are the color rules that I asked you to come up with yesterday. Remember, I said 4 rules? Well, here's 3 of them. Red plus green, yellow. Red plus blue, magenta. Green plus blue, cyan. And then red plus blue plus green, white. So R, B, G equals W. Those are the 4 rules. Okay, so where does color come from? So we got some notes here. Remember, the color is not inside the object. It depends on the reflection from the object. And so the object contains atoms that either absorb or reflect more one frequency or 2 frequencies more than others. They're not just reflecting 1 frequency. Sometimes it's 2 or even 3 frequencies that are being reflected. So, like if something absorbs Roy Biv, but it lets the green reflect, then it's going to appear green. If something absorbs Roy G and IV, but it reflects B, well, then that's what you're going to see. So here's some examples. So we've got,
If you tap them, they change music.
there you go. Thanks for my music show. Okay. Close the door, buddy. So here we go. We've got white light coming in, so Roy G Biv coming in, and the paper absorbs Roy Biv. So what's left? Just think of what's left out of here. Basically, it's like a subtraction problem, right? You can subtract the R, the O, the Y, the B, the I, the V. The only thing that's left is G. So it's reflecting G, or green, and green frequency light is just going to appear green. Let's say that we absorb Oi G Biv. Well, the only thing that's left is R. So it's going to reflect red. And what's that going to look like? Red waves look red. What about something that absorbs Roy Biv? Well, it's going to appear green. What about this? We've got 3 colors, RGB, and the pigment absorbs R. What's left? G and B. So what color is that going to be? What's green and blue? And you can go over here and figure that out. So this is where things get a little more complex, and you can't just freeze. And you can't just just immediately say what it's going to be. You got to think about the mix. Remember, blue and green, when you mix them together, you get this, and this color is called seriously, it's going to reload. Oh, here it is. Blue plus green, cyan. Okay. Let's get a little bit more complex. Oh, okay. So Roy G Biv absorbs Roy G Biv. What's that going to reflect? Nothing. How's that going to appear? Black. What about this one? Roy G Biv. And it absorbs Y G Biv. So that means it's reflecting what? R and O, which is red and orange. And how's that going to appear? What's red and orange combined to make? Is that on this thing? No. Red and orange. What's that going to make? Well, so we know that red and green makes orange. All right, so if I had, say, some orange and I added more red to it, well, I get some reddish orange. Maybe some kind of, I don't know, burnt orange or something like that. Okay. We've got more. So practice with these, right? Try them out. Pause it right now. Go ahead, pause it. Try these. Did you try them yet? Pause. Okay. So let's see. If we absorb, what's left? We're left with G and B, green and blue. What's green and blue make? Cyan. This one leaves you with red and orange, same as that other problem. This one leaves you with red and blue, so that should get you your magenta, which is like a purpley color. And this is going to get you just, oh, so you've got red, green, and blue, and we can absorb all these colors, not all of them are present, but it's going to be red. Is it time for another music show? It just plays music. Oh, it's me. Nice.
You're a doggy. How many more minutes? You're a chicken.
Okay, second part, color filters. So combining filters to make a color. So this is really useful for photography and making cool pictures. So for this, we're going to use a different sim, and it's this little light and color filters interactive on the physics classroom, and it looks like oh man, it's taking forever. Okay, a filter. A transparent material that selectively absorbs certain colors of light and transmits the remaining colors through. In this activity, you will explore the effects of filters on the colors of light. Somebody was exploring and now they're not exploring. So we're going to use lasers mode. And here's our first thing to do. We want to make dark red. So let's think about how much gets absorbed of each of these colors. How are we going to make dark red? Let's go. Do, do, do. Come on, Nerd Island Studios, you can do it. There we go. I want to make dark red. That means I want dark red to pass through. Okay. Well, that's one way to do it. What else blocks other colors, letting only red go through? All right, like what if I put a magenta filter? What does that block? Oh, magenta blocks green, but lets blue and red go through, right? Because magenta, remember, magenta is made of blue and red. Okay, well, now I want to block out the blue, but let the red go through. What else is made of red? Let's try yellow. So why did that work? What's yellow made of? Remember, red and green. So a yellow filter is gonna let red and green go through, but it's gonna block blue. So since I wanted to block the blue, right, see it ends right here, and then this magenta filter, because it only lets red and blue go through, it doesn't let green go through, and so I get dark red. So oh, that's not what we're supposed to do. My bad. I'm sorry, I jumped ahead. Okay, well, since I can't erase that, let me just, okay, go back. So let's see. If I put the red filter, that's what we're supposed to do for this part. Sorry. Let's dump these. So if I put the red filter, we just want to say what it does. So a red filter filters out anything that's not red. So you get 100% red, 0 green, 0 blue. So basically it'd be like this. So 0% of the red gets absorbed, 100% of the green gets absorbed, and 100% of the blue gets absorbed. If I do a light red filter, this. I'm going to get this out of here. Then we have 100% of the red and 50% of the green and 50% of the blue. All right, that's what this does. It filters out half of the green and the blue, lets all the red pass through. So that would look on the wrong thing. That would look like this. So none of the red gets absorbed, half the green gets absorbed, half the blue gets absorbed. Let's try dark green. Oh, the pain. Okay. So just like with the dark red, we've got all the red gets absorbed, all the blue gets absorbed, none of the green gets absorbed. Hopefully you can see here, just like I said in the handout, we're taking basically this number and subtracting it from 100 to fill in our table. And so all the red gets absorbed, none of the green gets absorbed, all the blue gets absorbed. And you get the idea. And these are going to change down here. These ones that are combinations of these primary colors, they're going to change, right? So for yellow, cyan, magenta. And I'll let you finish the rest. Okay, now we're going to look at the filters on a light bulb. And so you're going to apply a white light bulb that has all three of the colors and see how to create these colors. So how could you make blue with two filters? Okay. So how could you make some blue? Well, let's think about how we could make blue. If I wanted to make blue with two filters, I could, and this is what I was doing before, I could filter out, let me turn my light bulb on, excuse me. Oh, my bad. I can filter out the green, and then I can filter out the red. And it gives me blue. And notice that the order doesn't matter, doesn't care. Okay, so that's how to do this with two filters. So I put dark magenta and dark cyan. Now, if you want to make periwinkle, you need 50% red, 50% green, 100% blue. So let's try making that. So when you see those 50s, that means you're going to want to use some of these light things. So we want all the blue to go through, but we only want half the red and the green. Oop, that's not it. Here we go. I think that's what we were asking for. Let's just double check. 50% red. All right, see this 50% red, 50% green, 100% blue. Let's check and see if we got that. 50% red, 50% green, 100% blue. So this is the color periwinkle right here, this kind of light sea gray blue color. So that's the idea with this. It's just seeing what filters combine to remove light. And then your last assignment is to, after you're done with some of these, is to think about how you could make a ball that appears white in white light, and how you can use that with red, green, and blue lights and cyan, magenta, and yellow filters to make the ball look red. So think about 3 ways you can do that. And you can play around with the answers to this with this little simulator that we just used. That's it. All right. So try them out. And that's it. Have a great rest of your day. I'll see you tomorrow for another Zoom.